Hello there, Nareg is here. Today I'm going to solve the third exercise from first session 2015 chemistry related to electrochemistry reactivity of metals. A chemical reaction occurs when a metal strip M is dipped in an aqueous solution containing ions of another metal M prime. If the metal M has a greater tendency to lose electrons than of the metal M prime, in such reaction energy is liberated in the form of heat. Experiments are performed as shown in the setup given below. So you have a beaker A with Zn strip immersed in dipped in CO2 plus solution. The temperature is increasing, of course. The second one, beaker B, we have Ag immersed dipped in a solution containing CO2 plus, and finally CO strip immersed in Ag plus. Again, the temperature is increasing. So from this we can deduce in which case we had a reaction. The reaction that took place in the two beakers A and C, so it's only A and C, B there's no reaction, are represented by the following equations. In the beaker A, Zn plus Cu2 plus, it gives you Zn2 plus Cu. In beaker C, Cu plus 2Ag plus, it gives you Cu2 plus 2Ag. Remark, in beaker B, Ag plus Cu2 plus, no reaction occurs. Show using oxidation numbers that the reaction that took place in heat in beaker A is an oxidation reduction reaction. So we will have to say that this is what is happening in beaker A, Zn plus Cu2 plus, it will give you Zn2 plus Cu. So Zn, its oxidation number is 0 because it's a simple element. Cu2 plus is +2, it's the charge. Zn2 plus is again +2, it's the charge, and Cu is 0, it's a simple element. So for Zn, the number of oxidation is increasing. Number of oxidation is increasing from 0 to +2, so we have an oxidation. As for Cu2 plus to Cu, the number of oxidation is decreasing, we have a reduction. So since we have oxidation and reduction at the same time, we can say that it's a redox reaction. Indicate the oxidant in the reaction that took place in the beaker C. In the beaker C, we have the oxidant that should undergo a certain reduction. So it's Ag plus, which is undergoing a reduction in order to be transformed to Ag. So we have this is Ag plus. Classify the metals Zn, Ag, and Cu in an increasing order of their tendency to lose electrons. So let's check the first the reaction that we had. Cu plus to Ag plus. Cu is being oxidized. As for Ag, it is undergoing a reduction. So Cu, it has a tendency to lose electrons much higher than Ag. And as for Zn and Cu2 plus, we have Zn losing electrons much more easily than Cu2 plus. So we will have Zn and then Cu and finally Ag. This is the tendency, the increasing tendency to lose electrons. All right. A galvanic cell is constructed as shown in the adjacent figure. Write the oxidation half reaction of the reduction half reaction that took place in the galvan. So we have Cu and Ag. Between Cu and Ag, we know that Cu is the anode, Ag is the cathode. So we are looking to find out the half reaction of the reduction. We have oxidation, half reaction, and reduction. So oxidation will be Cu being transformed to Cu2 plus 2 electrons, and reduction we will have Ag plus 1 electron, it gives you Ag. So as you can see, these are the half reactions that take place as oxidation and reduction. Deduce the equation of the overall reaction when the galvanic cell is set to function. The overall reaction will be the one that we have in the beaker C, where we have Cu plus 2Ag plus gives you Cu2 plus 2Ag. Of course, you have to multiply the reduction reaction, half reduction reaction, by 2. Verify that the reaction of this cell is due to indirect contact between reactants. So in this galvanic cell, we do not have a strip of Cu immersed dipped in Ag+, just like the case of beaker C. This is a direct contact between reactants. As for our galvanic cell, it's an indirect, plus it is linked by a salt bridge. That's why I can say that it's an indirect way of having this oxidation reduction reaction. That was all for this exercise. I hope it was helpful. I'm going to ask you to subscribe to my channel. You'll be notified whenever I upload new material or new videos. And I'm going to ask you to, I can share with you my Instagram and Facebook account. You can contact me directly, or you can simply leave a comment below. That's all for this time, and see you later.